During a chemical reaction, whether it is exothermic or endothermic, bonds of the reactants are first broken before new bonds are formed in the products. For a reaction to occur, the reactant particles have to collide. If the reactant particles collide at low speed, they may just move apart without forming the product. Such collision is an ineffective collision. Usually, energy is needed to break bonds. If the reactant particles collide at high speed, they possess sufficient energy for breaking bonds and starting the reaction. This kind of collision is called an effective collision. The energy profile shows the energy change of chemical species during the course of a reaction. Consider an exothermic reaction. Initially, methane molecules collide with oxygen molecules, but they do not have sufficient energy to break bonds and start the reaction. A flame can supply the energy required to start the reaction. The activated complex with maximum energy is formed in the transition state of the reaction. It contains partially broken and partially formed bonds. The energy difference between reactants and the transition state is the activation energy. At this point, bonds break and new bonds form. If it is an exothermic reaction, energy of the products, that is, carbon dioxide and water, is less than the energy of the reactants. The energy released supplies the activation energy for other molecules to react. Consider an endothermic reaction. Ammonia molecules collide with each other, but do not have sufficient energy to react. A flame can supply the energy to break bonds. Afterwards, new bonds form among the atoms. In an endothermic reaction, it absorbs energy, and thus the energy of the product is greater than the energy of the reactants.